Alright, okay. Assalamualaikum. And good day, everyone. So, last but not least, on the lateral earth pressure of soil, you have to learn about the Coulomb's theory. So, previously, you learned about the Rankine's theory that have been mentions that there was a frictionless between the wall and the backfill. However, the Coulomb's lateral earth pressure theory, it remains the standard choice of analysis because he used a different way to get the coefficients of the active and passive pressure. So he developed this study on the lateral earth pressure back to 776, and still engineers love to follow this theory then. So, what's the difference? The Rankine theory have mentioned that the retaining wall and the backfill have no friction, but different way with the Coulomb. Okay, Coulomb theory assume, okay, the retaining wall is a wedge type. Okay, berbentuk wedge. Okay, so either they have a no slope or it can be with the sloping. Ada slope di sini. So you will see what are those. In fact, why I draw like this, because the retaining wall also in the wedge, berbentuk wedges, right? Dan ada sudut dia juga. However, if there is no theta here, so you assume it should be 0. But as long there ada sudut di sini, then you will count it as a theta. And Coulomb theory as well, what they learned, you will have to find the pressure acting behind the backfill. So must say that you have another angle. So Coulomb's theory, however, you will get few angles. Akan ada beberapa sudut. Compared to Rankine, there's no angle, only for the internal friction angles. Other than that, there's no angles between the retaining wall and the backfill. But Coulomb theory, you have it. You have a certain angles, which I will explain later soon. So here are the angles. So assume that failure occurs in the form of a wedge. So if you can see the drawing here, boleh tengok drawing here, dia bentuk wedges, like a cheesy wedges. So bentuk wedge, and you found out that there are certain angles. We have alpha, we have theta, right? Theta ni adalah sudut retaining wall on the frictional surface. Okay, sudut retaining wall dengan backfill. Dan we would like to find the forces, but since ada sudut, okay, ada sudut di belakang antara retaining wall and a backfill, so then you have another angle here, delta. So you have alpha, you have theta, and you have delta. Alright, if I mention this is alpha, so you should know this is alpha, this is theta, and this is delta. Sometimes there's books, okay, there are books that use a different symbol, but then you have to understand what those symbols are meant. Okay, so here, since Coulombs assume there are friction between the walls and the soil, so that's why you will need to get those angles. And Coulomb also took into account the inclination. Okay, dia ada inclination. Inclination tu di mana? Di sini. So let me erase this if I can. Alright, I couldn't get the eraser. So here again, the inclination of the backfill is sloping at an angle alpha. Okay, sudut yang antara tanah ni dia ada slope di belakang retaining wall. So when they are slope, ada slope di belakang retaining wall, then you will get it as an alpha value. So the wall face is inclined at angle theta. So ini wall, okay, retaining wall, bukan tanah tu, bukan backfill. So wall punya inclination. So theta here is a wall punya inclination. Wall inclination. Tadi alpha adalah backfill inclination. The third one adalah the angle of friction theta, okay, between the wall and the soil being retained. So sudut di antara friction delta antara wall ini dan juga backfill kita yang belakang. So basically, if this is your retaining wall, so we would to know the force acting here. So sudut yang conjunction with that is adalah delta. Okay. So to get that, this is the active coefficient yang digunakan oleh Coulomb. It's quite lengthy, but then again, you have to be careful with the symbols. Okay, you have to understand what those theta, delta, internal friction angles, all the symbols. So go back to this. So we have the coefficients of active earth pressure, Ka. The first line, cos square times internal friction angle, Phi, minus theta. Theta adalah sudut di belakang wall. Cos kuasa 2 theta, sudut di belakang wall, retaining wall, times cos delta adalah sudut di antara acting force dengan soil and wall, and then plus tambah theta, and then you kena kalikan all of that with 1 plus sin delta plus phi times sin phi minus alpha bahagikan dengan cos delta plus tambah theta kali dengan cos theta minus alpha. Okay, dan apabila ditambah dengan 1, you have to square it with 2. Okay, punca kuasa 2. So mind with the signs. Okay, at the end of the day, once you get the coefficient, sama juga, okay, sama juga dia punya active force dalam bentuk segitiga. So apa yang you nak adalah force equals to panjang kali lebar. Okay, setengah kali panjang kali lebar. You have the height here, h, di belakang retaining wall, and then you have stress equals to Ka gamma h. Alright, so ada sign. So sign ni adalah sign effective. So what if you don't have that effective in your question? So it's fine. So you will use the total punya value. Okay. Okay, so this is for the coefficients of passive earth pressure untuk Kp. So sama juga, but the only thing is all the signs there. So Kalau KP, you will go for the phi plus theta, right? And then cos theta times cos delta, but now it's minus theta. And then we have to times with 1 plus square root of sine phi plus delta sine phi plus alpha, but this one you have to go with the minus value. Alright, cos alpha minus theta. And then baru you calculate all this and then kuasakan dengan 2. So similar, you will get for the force per unit length. And then finally you nak dapat gamma as a location dia. So location dia sama jugalah. Equal to y equals to 1/3 of the h. Okay, so let's see for the example. So determine the total active pressure. So the question asks for the active pressure per foot of wall by Coulomb theory. Okay, by Coulomb theory. So kalau Coulomb theory, so you have the backfill. Tapi some of the questions you might not get or don't have the backfill punya sudut. Okay, so you can assume that it will be the 0. Tetapi for this question, you have sudut alpha which is 5 degree. Okay, sudut ni apa? Ni backfill. Tanah yang you backfill ni, sudut dia adalah alpha. And then you ada theta, sudut antara retaining wall, okay, dengan backfill. So you ada theta. And then you ada delta. Okay, force acting. And you have sudut delta here. So semua maklumat ada diberikan. You have alpha, you have theta, and then you have delta. And then here, extra, soil classification, you have gamma equal to 15 kilonewton per meter cube. You have phi and you have theta. Okay. So let's see how to solve the questions untuk Coulomb theory and the lateral earth pressure. So we know that Coulomb theory will give a few angle, but then you have to determine which angles should be used for which part. Okay, so yang membezakan antara Rankine dengan Coulomb, coefficients of active ataupun pressure punya calculations ataupun formula will be slightly different. Sebabnya Coulomb akan ada angle, but Rankine hanya ada internal friction angle, phi. Okay, so let's do the solution. So soalan tadi, they already gave the angles, alpha angle, theta angle dan juga delta angle. Dan dengan ketinggian 10 meter. So first you have to key in all the angles informations in the equations. And please do so. So to check if your answer is correct or not. Okay, so I believe KA equals to 0.3893. So let's check if you get this number. And it's really straightforward. Why there's no groundwater table, type of the few layer types. So it's quite simplified. The Coulomb theory is quite simplified, and it's ignoring the effects of the groundwater table. Okay. And then at the end of the day, nak cari dia force dia. So come back with the formula F A equals to setengah kali KA kali gamma kali H kuasa 2. And then you will fill in this value. And lastly, you will get the location. So sebabnya, we assume that pressure distribution membentuk segitiga, masih lagi membentuk segitiga. So height is H over 3. Okay. Okay, so it's quite simple. So please complete your sets of questions and let me know if you need more examples. Thank you.